Hello, welcome back to the channel, and in this video we'll look at base name and try to finish um, the various Hello, welcome back to the channel, and in this video we'll look at base name and try to add options um, and yeah, try to finish it. So let's see where we are right now. So last time we saw if we provide base name with no arguments, it basically prints a message. If we provide it with a path or a name, it'll give us the name of the file. And let's try one more example. And we saw how to compute the name of the base name of the path. We basically start from the very end of the string and basically keep on moving forward until we see a slash, at which point we know to stop, and we compute the base name as everything after the slash. Now let's look at the base name utility again and see what it does. It provides us a bunch of different options. For example, A lets you provide a few different any number of different paths, and it'll give you the base name for all of them in each line. So that's easy. And then the -s option removes a trailing suffix from the path. For example, if you say -s .h include /stdio.h, it'll give you stdio because stdio.h is the base name, but you want to remove the suffix .h, so it'll remove that from the very end. So one thing to keep in mind, it will not remove .h from any other place, only from the end of the name. And also, if you basically say base name, a path, and a suffix, it'll basically remove that suffix from the name. So it's similar as providing -s .h and then the name. And so now let's try with the first option, the -a option. And to do that, let's look at a couple of examples. So base name -a user, let's say sort user compare, and we get two different the base name for both the names on two different lines. Now let's try and see what we get in our program. If we just try this, so which is to be expected because base name assumed this was the name and tried to get the base name of this particular path or name, and it basically gave us the whole name. One thing to notice is that the behavior of our base name is completely correct in this case. If we look at oops oh yeah, so this is, let's try base name Yeah, so what I want to see if we can, yep. So the point I was trying to make is this. So the base name of -a is -a. This is just here to make sure that base name does not get confused with this -a. If you just provide base name -a, it will assume that's like an option and not a name. So to provide a name to base name, yeah, so we have to do something like this, I guess. Well, that's not too important as of now, but just to make sure that the behavior of our base name is perfectly valid. Now what we have to assume is that every argument after -a is a different name, which the standard base name also assumes. So if you provide any other switch after that base -a and its arguments, it'll assume that's a name and not another switch. So before that, let's think about how we can actually implement that. So we just have to do one thing, right? If we could get all these different names after this -a, so we'll first check, is there a -a? There is. Perfect. Then we look at everything after -a. We're going to assume that they are all separated by space, one space, or number of spaces, doesn't matter. And then we have to do this this particular operation on every single name. So now we get to this very important feature of any language. So if you have to perform the same exact operation on every single element, why not just have that piece of code in a single place, and we will basically change the input to that piece of code. So what I mean to say is that the only difference that's going the only thing that's going to differ between different names is this particular variable name, like which will take on the value this at first and this at first, and then there could be like any number of values after that. And if we just are able to perform this particular operation on that particular name value, we should be good, right? So Python calls this feature a function, and a lot of you may be familiar with it. So in Python, a function is defined starting with def or define, however you want to call it. So I call it def, and so then the function name, then the brackets, round brackets or braces, and then an argument, any number of argument to the function. So let's say this function is going to compute x plus 1. So, and note that I did put a couple of spaces on the new line so that Python knows that this piece of code belongs to this function. In Python, white space is how you identify regions of code, and So you basically put a colon and then you say begin a new piece of code, and then you put space, and any code that has the same number of spaces will belong to one region of code. So that means this and this piece of code belong to the same region, this piece of code belongs to the same region, this whole piece of code belongs to this region, and this piece of code only belongs to while. This print is again outside the outside while, so this is not included inside while. And so let's try this thing. So let's try calling this function with some argument x set to something. So what happened here is when we said f curly brace 2 and another curly brace, is it substituted this x with 2, and simply it became return 2 plus 1. 2 plus 1 is 3, and return is a way of saying return this value from this function, or because you cannot access this value from outside the code, outside any other function, so you have to return the computation result from this function using a return statement. And that's what return statement does. It just returns a value from a function. And now let's do the same here, right? So let's say def get base name. I guess that's a good name for now, right? And we don't really have to do anything. We'll just go over, cut this code, and just format it a little bit and replace our original code with that. So what we basically did, we said, oh, that piece of code needs to be run for every single element. Why not just put it in a single function? And now you have to make sure that this, if you rename this parameter with something else, you will have to change this at this particular variable at every other place, not name index but name. But I simply named it name here, so I don't have to do that. Now let's try this function again, and we say Python base name, Python3 base name, and how about just try like a very simple example, right? And we get the same result. And the good thing about this program, this version of the program, is that we not only did we made it easier for ourselves for implementing arguments, but we also made it easier to give that particular piece of code a name. So before that, all of this code was here, and you had to keep track of what exactly that code did or what its purpose was. But now we have a name for it. We say get base name, and which should like a better idea is to return this name from this function, but you get the idea for now, right? That we are getting the base name. Right now we're printing it, but we can very easily just return it from here and then print it in this region. We'll worry about that later, but for now we let's try finishing up our case for many different when many different elements are specified or names are specified after the -a switch. And how do we do that? So right now I'm just going to comment out everything. Oops. So I'll comment this out so that we can go back and see what things look like. So now what's a great thing about the sys.argv array or list is that it basically breaks everything down for us. And so we don't really have to worry about, oh, this is a different name, this is a different name, and there could be one or more spaces, and we need to do that, write code for that. So that's a pretty cool feature. And so now our problem boils down to this. We have a sys.argv where everything is separated by a space. If we find the index of this -a, then we know that every element after that is a different name, and we have to simply run get basename function on that particular element. So let's get back to the shell again and see how we can find the. So I'll copy this, and this is one really great thing I like about Python, is it lets us do things in the shell so that we don't really have to, compile this, not compile this, I mean save this, edit this, save this, and then like run Python and name of the script, which is still like better than C++, where you have to maybe do a multi-minute or multi-hour compile. So now we have x, which is this list, and index is a function which tells you if an element is in the list or not. So if I say x.index of -a, gives me 1. However, if let's say I do -z, it throws an exception saying it's not in the list. And now we have to also remember that a user may not give a -a argument to our program. So if we can simply just say sys.argv.index -a and not handle that exception, because our program will just crash. So this brings me to my next point, is index exception handling. So let's see this. So if I say except index value error, because we don't because there was no such value inside the index, we'll just print for now an error occurred. Alrighty, so this is how we handle exceptions in Python. There's a try code block. We say try and a colon, and then we write all of the statements we want to write and assume that they are going to run in a normal fashion. So we're going to assume that, oh, there is probably in this particular value inside our list. If, however, there was no such value, then this code will raise this exception, a value error exception, which could be different for different purposes, and we'll say except try this thing, and except there was a value error exception, do this. So we are basically saying if you cannot, if you run into an error doing all these statements, running any of these statements, and this is the particular error, then do this. And that's what exception handling is. You handle errors if you can handle them at that point, or you just let it move up the chain. So there is, it's more complex than that, but for now we just need to know the basic syntax and how to handle exceptions. So let's try this, right? So now we know we don't really need that. We'll try and see if there is an index. So we'll say index is sys.argv index -a, and if there's a -a index, what do we do is everything after that, we want everything after that, right? So the simple thing is we'll say names equals, and if you remember this from the last time, we can slice this list with the index, right? Index plus 1, because we need everything after this -a up to the end of the list, because we are going to assume that everything is a different name. And let's try that here too. So if I say x and x.index -a plus 1, it gives me everything, because this was 1 and 1 plus 1 is 2, because we want everything after a, and this is the list we get. Now you may ask, what happens if x did not have, only had -a and nothing else? Let's try that. It'll give us the empty list because there was nothing after that. So it'll become, so indexing, if we say 0, 0, it's an empty list. Any index :index, like that slice, is the empty list, because you're trying to slice from that index to that index and there's nothing in it. So now we know that this behavior will be right if there's nothing after -a. So, and this will give us all the elements or the names inside the command line argument. Well, let's we know that, right? Now what we want to do is something like this, and I'll get back to how a for loop works. And you know what, and if there is a value error, we're going to assume that we'll just do the thing that our program is already doing, is that the first element is a name, and we basically print the base name of that. Now let's get back to this for loop. So how about we take an example? Let's try this thing. X equals to this thing. Okay, so x has 4 elements. If I say for e in x, print e, so for e in x means give me an element of x one by one, store that in e, and so that I can work on that element and then move on to the next. So this code says for e in x, So e is assigned to basename.py first, and when we do a print e, we print that. For e next, now e becomes -a, we print that. E becomes this, we print that. E becomes that, we print that. And so this is what we are doing in this example. For name and names, we know all the names are in this array. We are saying, give me a name one by one, and then I'll simply get the base name for those. Now let's try this. Woohoo! So it works, right? Let's try with one more example. It works in the case where there was no -a, just a single element. And there's one point I would like to add is we added a new functionality to our program, and then we also have to make sure that we don't break the functionality that we already have. And so there's something called testing, like program testing or unit tests. There could be integration testing and a bunch of other things you can do to test programs, and we'll get into those examples, and we'll start testing our programs when we write more not even more complex. We'll probably look into testing for base name in a few tutorials when we are probably done with writing the whole utility, and so that'll give us a good idea of what to test and how to test, and I think that'll be a helpful exercise. But for now, we'll just rely on simple try it and see if it works. Okay, perfect. So I guess we have got the -a done, right? And let's see more options. -s suffix, remove a trailing suffix and implies -a. Okay, so if I say -s and .h include stdio.h, so what this means is remove this .h from this base name, so it'll be, so the base name would evaluate to this, and then it would basically remove this part of the string if it's there. If it's not there, we won't remove it. So it's got to be one like complete match. We won't like remove a string if it's not there, like, so we won't remove this dot. If this was stdio.c, we won't just remove dot and just leave it like that. If we find the whole match, only then we remove that. Also, it implies -a. What that means is if you have base name -s and dot and a suffix after that, everything else is considered to be a -a. So that means this -s applies on every single name, which is like very similar to our -a. Okay, now so we did one thing in this example. We added -a. Now assume that if we try adding support for -a, we could do one thing. We could try this. If exception occurs, you can try this, and then here we can, so this value error occurred because -a was not there, and then we can do try -s, right? And inside this except, because you can nest try and except blocks inside another try and except blocks, then we'll say, oh, try finding the index -s. If it's there, do something like that. And if it's not there, then do this. But you see how difficult that will be to manage, because if you, let's say we add 5 different options, we'll have like try except, and then inside except try except, and then that inside that except try except. That'll be no fun. So how about we keep all our options inside a list, and then try and see if any of them is specified on the command line. So okay, so what I'm trying to say is this: if I say 1 in X is true, so if I have a list and I use this in operator, we have seen that in a for loop, but in context of a list, if we say for example 1 in X here, it means is there 1 in this list? And yep, there is, so it returns true. If you say 4 in X, it says false. So how about we do the same here? Rather than having those try catch blocks, why not write these options, right? Options equal -a -s and -s for now, and for option and options, so we go over each option. If option in option, if option in sys.arg argv, whoops, there we are, then do something corresponding to that option. So, and pass basically is like do nothing. It's almost equal to the curly braces in Java or C or Python, C++. So if you want to leave something empty, just write pass. And now, okay, so this is good, but this also gives me an idea. If we could also bundle the function, the particular kind of function, with this argument or this option, we can simply apply that function to sysarg argv, and it'll do the work for us. So what I'm getting at is this: we know this is what happens when we apply option A. So option A arg, and then I'm going to paste that, and because I name it argv, so I just remove that because I'm not interested in sys arg. This is more general function, right? So option A. So the point I'm making is this: let's even get rid of all of this, and now I'll get into this very soon. Option A, option, comma, option function, option function sys.argv. Okay, and we'll get back to this later. So let's first look at what this means. A 1, 2 here. So this looks very similar to a list. Now this is called a tuple in Python. It's almost the same as a list. You can get the indices, elements from a tuple. You can do the same exact things with a tuple. The only difference that between a list and a tuple is that tuples cannot change in size. And I just use that here because we know this particular thing is not going to change. So this, if you look at it, this is kind of interesting. What I'm trying to save here is an option, the option and a particular function which processes the argv list when that option is encountered, and then when that option is encountered, it calls that it calls this function. And this is interesting. Let's dive into that. I'm going to try and do this. Let's say 2, none. So you know that print is the function which prints anything, and let's say our option is for now 1, right? And we've seen a version of for loop which goes over elements in a list and sets it to something 1 by 1. You can also see that Python lets you break down a tuple in a list and assign it to 2 different variables. So what's happening here is options is this list, and the first element in options is this whole tuple, and then we are saying for option comma option function in options, so the first time option is set to this string and option function is set to this particular function, and then option is set to this string next time and option function is set to none. A none in Python is a value which says none or empty or yeah, so there's nothing there because we don't really have a function for this switch s for now. So let's try and see what's happening here. So if I say option opt function in x, let's try and print what we get every time, right? So like I describe here, option gets this value, option function gets this value, and this is Python's way of printing the function print because this is what it is. So it says 1 built-in function print, and then next time opt is 2, opt function is none, and we say 2 and none. Okay, so that's pretty cool. Now what that actually gives us is we don't really have to do those try and catches. We can check to see if an option is in sys.argv. If it is, we just pass that argv array or the list to this function. In this function, we know for option A does this. It computes the index of -a, and if you may be wondering, oh, what if this code throws an error? But it can't, right? Because we know that this option it is indeed in sys.argv, and that's why we can be sure that whenever we call this function, we're going to assume for now that whenever we call this function, there is a -a in this list. It might, for some cases, it might not be. If you're writing code, you may try it and handle it here, but we're gonna assume for now. And then we know that, okay, this is what -a does, and that's pretty powerful, because we can now, okay, first of all, let's try and run this thing. Okay, so you might be confused at this output, but it's very easy to explain. This first sort is printed by this option a function, because it finds an -a in sys.argv. It calls this function, and then it goes here, prints the base name of every name, and then returns back here. So when functions return, they return to the line after they have run. So once this function returns, it returns just after this function is done. And then we reach here, because this for loop is done. We don't find any -s, and then we get here, and then we start from here again. To fix this, we can keep a boolean option found equals to false, and we say if we find an option, we say option found is true, and then we say after this for loop, if there was an option found, then we don't really need to do any of this, because we have already taken care of that. And if we try this now, okay, oh, if not option found. So if there was no option found, then we print the base name of the name. If there was an option, then we have already done things. So yeah, right. And now let's extend this program for our option -s. So option s it'll take a list, which will be the sys.argv list, and then we'll do almost the same thing. So how about we copy and paste this? Say this is s index. We're gonna look for -s, -s, sorry, and now we have to do two different things. Okay, also yep, so now we do two different things. Is find the suffix, and the suffix is at argv s index +1. So this suffix is this suffix I'm talking about, this particular suffix. So if the index of -s is 1, so 0 1, then hyphen of this suffix, index of this suffix is 2, and that's exactly what I'm doing. Let's rename that. So this suffix lives at index of this -s +1. So basically just saving that, so we don't really have to, do this thing, like write this down again and again. And now our names is -s index +2, s underscore plus index plus 2 because this is the index of hyphen s, so plus 1 is that, and everything after that is the list of names. And then we'll later go into error handling, where what if there's no suffix, what if there's no list of names, which was okay in case of hyphen a, because we don't really have to worry about if there's no other suffix here or no other names, because we don't do anything. We basically we make complaints saying okay, there was no but for now that's fine. We'll go get back to error handling and then we'll see, but for now let's assume there's a suffix. The user is, we have a good user, he'll provide us a suffix and he'll provide us a name, at least one name. Okay, so now what we're doing is, like, we're going over this list one by one. We're saying this is name in names, and so we get the base name out of this. So our base name would be this string, and we have to check whether this suffix is there at the end of this string, and if it is, remove it. And now we'll do it with everything we know. We won't introduce anything new. So let's try. So right now we have the base name, so we have this string. If we could get the last length of suffix characters from this string, so the length of suffix is 2. If we could get the last 2 characters of suffix from this string, then we can check to see if that matches the suffix. If it matches the suffix, then we can try and remove it, right? So let's start with step 1 or step 2. We already have this base name. Let's try and get these many number of elements from this string. So I'm going to say base name length of suffix minus and if suffix equals to base name minus length of suffix colon, and we'll just say pass for now. Okay, so this might be if you remember slicing, you remember that. How about we just copy this string here? Okay, and then we know that if we index something using the negative indices, it'll just gives it starts it from the very end, and so -1 would be the last element, -2 would be the second last. What if I say -1? Okay, -2. That's starting to make sense. So a suffix length was 2, and then we get that many that part of the string from the very end using string slicing. And now in Python lets you basically compare strings using the equal operator, which says are these things equal. So let's try that. Oh, that's cool, right? What if this was something else? Nope. So Python just lets you compare strings like equal, which is different from C or C++, where you have to do a string compare. C++ lets you do the same thing, but only with string objects and not character arrays. But in Python, you can do that for strings. So like, which is pretty cool, because that lets us just say if suffix is equal to the last that many elements of base name, then we know that they're the same. And so in this case, what we do is we print the base name without the suffix, right? And how do we do that? Print base name again, length of base name minus length of suffix. Does that seem right? So let's try that. So what I'm saying is, if we slice the length of s minus the length of the suffix, oh, right, because we start from the beginning of s, and we want to only include everything other than the suffix, and we know that the suffix is at the very end, so we need all the elements in the string up to the index of the first element of the suffix. And how do we get that? We basically subtract the length of the string, the length of the suffix by the length of the string, and that's how many elements we need to include now, and that's what our base name is. Perfect. And in the case there was no suffix, or the suffix was not there, we basically just print the base name, because we cannot do anything in that case. And then we go back here, and yeah, there it is. Let's try that. Let's try in this example. I'm just gonna do this. Whoops, what happened here? Did we save it? Yes, we did save it. So we get a type error. None type object is not subscriptable. That means this base name is none. And why is that? Oh yeah, okay. So base name. So that's okay. So the issue here is that this get base name function is not returning anything. It's just printing it. So let's also add code to return that. So now not only will it print it, it's just gonna, it also returns it. And a better thing would be just eliminate this print function. And so now everyone who wants to print it has to do it themselves. So if you remember, return simply returns that value from this function. Now we store in option A, we say store that from as the output of this function, and then we print it ourselves. And this makes it easier for us, because then we can save this, because then our code doesn't really need to have this weird side effect where we don't know what base name is printing, or we can control our printing ourselves. What if we don't want to print a base name, because you may just be interested in the base name and you're using it in some different computation like we are doing here. So we'll just print the base name ourselves. And so I'll make the change here too, and let's try this. Oops. that works. And how about this? That works. In this case there was no .h, so we just print the suffixes. And you see it's really cool that we were able to write a lot of this code and also able to refactor it with these simple functions, and then we were able to, you know, put them in a more sensible fashion than having a try and catch block every time. I think for now it might be a good idea for you to go over this code by yourself, write it and see if it works, find the edge cases where it doesn't work well, and next time we'll go over this, add this new option, and maybe look at some unit tests and see if how to test the output of our program. That'll be cool. Okay, till next time, bye.